grab any graph paper. I forgot to.
My bad, I should have told you that.
Yeah.
That's on me.
Yeah, you forgot to remind me.
My bad. Again, I'll take full responsibility.
Thank
That
you.
goes down.
Thank
Not a
you.
problem.
I thought I told you, Will. At the beginning.
Oh, everyone did. Okay? God. Okay. So here's the point of the lab.
You signed it.
So you had the fluid, and the first thing that you did is that you suspended it halfway down. And the whole point of the story is that you had some upward tension. So on any of these problems, and one of the main things you need to understand is that you have a balance between the gravitational force acting down, the buoyant force acting up, and the tension, okay? So those three values, the tension, which you're going to measure, the gravitational force, which is a fixed value, and the buoyant force, all three of those have to add up equal to zero because the system's in equilibrium. So the whole point of this story is that buoyant force is rho Vg, but remember, that rho is the density of the fluid. That's the volume that's submerged in G. So clearly, the more volume that's submerged, the more buoyant force there's going to be. So we got a little clever in terms of the units, in terms of what you're going to graph. So hopefully, and you can do this like two different ways. You could put like the aluminum and the iron slopes on the same graph, okay, and say, okay, hey, here's my water line. So here's my water. So you could have like, here would be like your iron slope, and this would be your aluminum slope. Okay, so water, boom, put them both on the same line. If you don't like that, you could put 4 different graphs. Okay, it's like, hey, I don't want to get confused. I just want to draw 4 different graphs, assuming that you have graph paper. So
I just admit it though.
okay, so I don't care how you do it. Just make sure that I can look at your graphs and know exactly what they are. So here's the point of the story. When you look at this in terms of units, so you've got tension, which is newtons. We're going to do that as kilograms meters per second squared. And then you've got area. Now your area is a fixed value. Okay, that's not going to change for that particular block. G is a fixed value. That's the same. So the only variable here is the depth that is below the water line. Cool. So you're only going to have 2 data points. You really can't even draw a line at best fit. You're just going to draw a line that connects the 2 points. So on your y-axis then, you've got newtons. So your x-axis is your area, which is going to be in meters squared. And then you got acceleration in meters per second squared, and then you have height, which is also going to be in meters. So if you look at what happens, those meters squared cancel out, and the only thing you're left with is kilograms per cubic meter, otherwise known as density. Okay? So it's kind of a clever way to look at that in terms of density. Now, so the whole point of this story, hopefully, was that you realize that you have water, and then you have the methyl alcohol. The density of the methyl alcohol was a lot less. So if you look at your buoyant force being rho Vg, then as you decrease the density of the object, of the fluid, so if you're comparing water to the alcohol, water is going to be more dense, so that should create a bigger buoyant force. So if the same volumes are submerged, the water should be creating a bigger buoyant force, there should be less tension. The alcohol has a smaller density, same thing, less density, less buoyant force, there's going to be more tension. So hopefully, but listen to your discussions about your graphs, maybe that didn't happen. Okay? So, anyway, so you should have a total of 4 slopes. Average slope, don't not make it difficult, and I know you all can, and I would just do like the positive values, okay? Technically they're negative, but we're trying to find density. It just works out that it's a negative value. And then on your experimental error, remember that's theoretical minus your experimental over theoretical times 100, okay? So that's either going to be the 1,000 or the 792, okay? Cool with that. Now, on the questions, and yes, do not answer the questions on the sheet. When you get into those questions, anybody have any questions on those? Danny,
4.
what's number 4?
The lab question 4.
We compare the water level of alcohol's buoyant force the same for each. Okay, and again, that's just what we just talked about. So if you look at how you calculate buoyant force, so on that question 4, you've got your alcohol. Imagine, Danny, imagine this. Imagine that you have 2 identical blocks. One submerged in water and the other one's submerged in ethyl alcohol. So if you look at how you calculate buoyant force, which is rho Vg, the Vg part of that story is going to be the same. It's the same volume, same gravitational acceleration. So the one that has the higher density is going to have the higher buoyant force. Okay?
Okay.
So there's your answer for 4.
Okay.
Okay? When you get to questions 6 and 7, pay attention. Are you talking about equal volumes that are submerged or equal masses that are submerged? Because there means 2 completely different things. Okay? So
He said 6 and 7.
just keep that in mind. All right. Anything else?
Can I see my answer?
Are we good?
The answers.
Going once, going
Right
twice.
here. It's underneath.
So here's how I want this sequence.
Very well.
I want
Thank you.
the lab itself, then I want the answers to the questions, and then I want the graphs. Okay? So lab, answers, graphs. Got it? Good? Grand? Okay. Shut off your camera.